Hello and welcome. I want to talk about the slope-intercept form of a linear equation. Now, a linear equation of two variables has a standard form of ax plus by equals c, where a, b, and c are just real numbers. This is what we call the standard form. So any equation that has x's and y's in them, not multiplied together, and the powers on them are 0 or 1, usually 1. Those will be equations of lines. The main form of an equation we'll look at is the slope-intercept form. And that looks like this: y equals mx plus b. And you've seen this before. M is the slope of the line, and b gives us the y-intercept. Technically, 0b is the y-intercept. Now, what's an intercept? Well, the intercept is where the line crosses the y-axis. The y-intercept is right here. It's where the line crosses the y-axis. And it always has the first component, or the first coordinate, 0. It could be something here. We could call that b, in fact, here. Where the line crosses the x-axis, we call that the x-intercept. And that's when the function, or when the function value, the y value, that's when the y value is 0. And so we could call that a, say, where that happens. That'd be like an x value of an a when y is 0. And this is a y value. The y-intercept is b when the x value is 0. So they're opposite, right? And by the way, the slope is our rate of change. You can think of it as a rate of change. It's a rate of change of y per x, as we've already talked about. The change in y per change in x. Delta y over delta x. So let's look at an example here. Let's look at, I don't know, how about y equals 2x plus 3. So here the slope is 2. And the y-intercept is 0, 3. Now how that translates to graphing is, we know the slope and we know the y-intercept, so we can graph this. For purposes of graphing, I'll often think of it, if it's a whole number, I'll think of it as 2 over 1. I'll put that whole number over 1, because then that tells me for every 1 the x increases, we increase the y by 2. So then we just need a starting point, because we can basically stair-step our way with the slope to graph this. You just need a starting point. Well, that starting point is our 0, 3. 1, 2, 3. Here's 0, 3. And we need to stair-step our way up to the next point. So we go over by 1 and up 2. So there's another point. We could go over by 1 and up another 2 and find another point. And we could even go left by 1 and down 2 to find a point, right? Left by 1, left is negative, down is negative. So negative 2 divided by negative 1 is 2, because negative divided by negative is positive. So you can go either direction to stair-step your way to finding other points on the line. All the points on this line are solutions to that equation, and they go through all these points. The slope will always be the thing multiplied by the x. It's the rate of change, and so you have to multiply it by how far you've gone horizontally in order to figure out how much the y value has changed from the starting point. I'll just write that right now. Technically, 3 is not the y-intercept. The y-intercept is technically 0, 3, so it depends on how picky you want to get. All right, so let's look at another example, just real quick. Second example, y equals negative 2/3 x plus 2. Well, slope. Here's our slope. And here's our y-coordinate of our y-intercept. So our slope, negative 2/3. And our y-intercept is 0, 2. And again, we could graph this if we wanted. Our y-intercept starts at 0, 2. There's our starting point. And we can stair-step our way. Now, when it's a negative slope, if I'm going to graph this, I'm going to either pick the top or bottom to put the negative sign on. It won't go on both, but it can be on the top or it can be on the bottom. The bottom number says go to the right 3. 1, 2, 3, and down 2. 1, 2. I've hit the x-axis now. I could go another 3 and down 2. 1, 2. Get another point. If I used this second number, the second slope here, 2 over negative 3, that would correspond to going left 3 and up 2. And I don't really have room to draw that, but if you were running out of room and you had to go the other direction, just take the opposites of those numbers. Instead of negative 2 over positive 3, it's 2 over positive 2 over negative 3. And that will just go the opposite direction, stair step in the opposite direction, and you'll get the same line. Okay, so one question we might want to ask is, well, what's the x-intercept of these equations? And especially now, let's look at the second equation first. The x-intercept, well, we already found it. It looks like it's at 3, 0. And remember, the x-intercept has always got a y-coordinate of 0 because the height, the altitude it's at, when it crosses the x-axis, is going to be 0. So this is 3, 0. Well, how would we find that just from the equation? Well, you can't just read it off like the slope and the y-intercept, but you can solve for it. You can plug in 0 in for y. So let's rewrite our equation over here. Y equals negative 2/3 x plus 2. And let's just plug in 0 for y. When we plug in 0 for y, plug in y equals 0. We plug in 0 for y, what do we get? We get 0 equals negative 2/3 x plus 2. And we just solve for x now. And this is something you can do for just about any equation with y's and x's in them. If you want to find the x-intercept, you plug in 0 for y. If you want to find the y-intercept, you plug in 0 for x. And you can see that over here in the equation. If we plugged in 0 for x, this whole term would go away, and we'd be left with just the 2. But anyway, so find this x-intercept, we just solve. Let's subtract 2 from both sides. We get negative 2 equals negative 2/3 x, and then we're just going to multiply both sides by negative 3/2. Well, what happens? Well, the negatives on the left side, the negatives cancel and the 2's cancel, so it looks like we just have a 3. And on the right side, we just have x. X is 3. Hey, we already do that. So, yep, that checks out. X is 3. So that's how you would get the x-intercept. Plug in 0 for y, and then solve for x. So let's try that up here. I'm going to go in reverse order here. Okay, let's plug in 0 for y. 0 equals 2x plus 3. Solve for x. Negative 3 equals 2x. Divide by 2. So our x-coordinate of our x-intercept is negative 3/2. So our x-intercept is negative 3/2, 0. The y is 0. That's what we plugged in. So that's this point right here. Negative 3/2, 0. If you have just the standard form of an equation, and it's just a quick way. It sometimes works. If the line goes through 0, 0, this doesn't really work. But I thought I'd mention this. So say we've got an equation that looks like, let's graph 2x plus 3y equals 6. Let's just keep it simple. So what we can do is we can just find both the y-intercept and the x-intercept. So let's find the y-intercept. Let's find the y-intercept by setting x equal to 0. If we do that, basically just cover up this term. It goes away, and you just solve, right? I made the numbers nice, so the solving's easy. So if x is 0, then you just have 3y equals 6, and you just solve for that. Y is 2. So the y-intercept is 0, 2. The x-intercept, you would plug in y equals 0, as we did before. And you basically, that involves just killing off that second term, because y is 0. And so then you just get 2x equals 6. And so x is 3. And so the x-intercept is 3, 0. And if you want to graph that real quick, you just go 0, 2. There's that one. And 3, 0. There's that one. Draw a line. Done. But you often want to know what the slope is, because you might need to know what the rate of change is, because that's kind of useful. So usually if you're graphing these things, or if you're just dealing with linear equations, you're going to want to get the equation into y equals mx plus b form. So if the equation isn't in slope-intercept form, and you need to know what the slope and the y-intercept is, just solve for y. I'll show you how that works. So let's start with this equation. Be similar to the previous one, except I could use 2x plus 3y equals 6, but I think I'm going to use 2x plus 3y equals 9, just to be a little bit different. So what's the y? So say we wanted to know what the slope and y-intercept of this equation is, of this line is, described by this equation. Well, we can't just read it off, so instead solve for y. Well, that means getting the term with the y by itself first, and then dividing by this 3 here. Both sides. So let's do that first. Let's subtract 2x from both sides. We get 3y equals negative 2x plus 9. And we divide both sides by 3. So that means y is, this 3 distributes to both of these. It's, in other words, you can split the fraction up. And so you get negative 2x over 3 plus 9 over 3. In other words, if you got negative 2x over 3, that's the same as negative 2/3 times x. And this b value is going to be 3. So we can now say the slope is negative 2/3. The y-intercept is 0, 3. And then we could graph it from there if we needed to. But that's all for now. See you next time.